G'day, hope everyone's doing well. So in this video we're going to be looking at rates of change and a worded question. So this one we're going to be comparing average rate of change and instantaneous rate of change. We'll be doing both for a question. You'll see I've put some information in the grey box there. That's for part B. Okay, so this here is for part B. So we'll get to that later and we'll just get into our question here. So the volume of a cube with an edge length x is given by this equation. V is equal to x cubed. Alright? So we need to find the average rate of change of the volume of the cube with respect to x as x increases from 2 to 4. Okay, so it's looking at those points from 2 to 4. So we've been given a function here, so we can now use essentially our average rate of change formula for our function. So for part A, we can use our formula for, and this is average rate of change. So an approximation for that is equal to the change of y over the change of x. Okay, your gradient. So if we're using a formula for our gradient, we can use when v is equal to 4, because we're going from, it's like y2, or that's like our y2 value. This is like our y1 value, v2. Then over our x2 value, which is 4, x1 value, which is 2. Okay, just remember this here is our gradient formula. This will give you an answer of 28 when you do it in your calculator. So we can stay here, or we can say here that the average rate of change from 2 to 4 is 28. And so the average I'm just going to say the average rate of change, because I'm feeling a bit lazy and you probably don't want to see me write. Okay, so it's always good to have a little short worded response for a worded question as well, but we'll get into B. Make sure you can do all this right. So B, find an estimate for the instantaneous rate of at which V changes with respect to x when x is equal to 2. So we're looking at the point x is equal to 2, and what we've got here is we've got formulas that we can use. Okay, so when you're doing this with a formula, you just need to pick a very small value of h. Okay, and you can approach it from the left or the right, it doesn't matter which one you use. Okay, so for this one, I'm going to approach from the right. So I'm going to approach from the right and use this equation. And I'm going to use a value of h, and we might use 0.01. 0.01. Okay. So with this, our instantaneous rate of change, well, an estimate for it, this is going to be equal to V of 2.01 minus, forgot the V there, and V of 2. Yet again, this is the same formula that we were using just above, okay, except we're looking over a very small gap. So it has an estimate for instantaneous rate of change, and over our h value, which is 0.01. So this here equals 12.06. So we can say an instantaneous rate of change is approximately equal to 12 when x is equal to 2. And we don't really have units here like centimeters or anything like that, so you can't really put a units here for our rate of change. You could put, yet again, no, you're not really, because we're not really given any units at all, so we don't really need to put units in the answer there. So this is our rate of change, and just remember, firstly, our average rate of change Okay, it's just like your gradient formula. Instantaneous rate of change, you're using the same formula here for the function, but you're looking over a very, very, very small gap. Okay, so just make sure you pick a nice small value for h. You probably don't want to go below 0.1. I mean, you don't want to go over 0.1 unless it's stated in the question. Alright, so hopefully this helped with working out worded questions with rates of change. Good luck.